Engines are everywhere, from your car to your bike, even in lawnmowers and generators. But have you ever wondered how something as compact as an engine can generate so much power to move an entire vehicle? In this video, we're going deep into the heart of mechanical engineering to understand how the internal combustion engine works, what makes it so efficient, and why it's been the driving force of modern transportation for over a century. Let's start with the basics. An internal combustion engine, or ICE for short, is a machine that converts the chemical energy stored in fuel, usually petrol or diesel, into mechanical energy. Unlike external combustion engines, like steam engines, where the combustion happens outside the machine, an internal combustion engine burns the fuel directly inside the engine cylinders. This is what gives it the ability to generate high power in a compact size. At the core of the engine is a series of cylinders, each containing a piston that moves up and down. These pistons are connected to a crankshaft, and as the pistons move, they rotate the crankshaft, which ultimately powers the vehicle's wheels. The movement of these pistons follows a sequence known as the four-stroke cycle: intake, compression, power, and exhaust. Let's break it down. In the intake stroke, the intake valve opens, and the piston moves down, drawing a mixture of air and fuel into the cylinder. In the compression stroke, the valve closes and the piston moves up, compressing the mixture into a smaller space, which makes the explosion more powerful. Next is the power stroke, the magic moment. A spark plug ignites the compressed fuel-air mix, causing an explosion that forces the piston back down with incredible force. Finally, in the exhaust stroke, the piston moves up again, pushing the burnt gases out of the exhaust valve. This cycle repeats hundreds or even thousands of times per minute. Now, you might be wondering, how do multiple cylinders work together? Well, most engines have between 2 and 12 cylinders. They're arranged in different layouts: inline, V-shape, flat, or even radial, depending on the type of vehicle. These cylinders are carefully timed so that while one is firing, others are in different stages of the cycle. This creates smooth and continuous power output to keep the engine running without interruption. One of the fascinating things about internal combustion engines is how efficiently they convert fuel into motion. However, they're not perfect. A significant portion of the energy from fuel, sometimes over 60%, is lost as heat. That's why engines need a cooling system, typically using coolant and a radiator, to prevent overheating. They also need lubrication systems to reduce friction between the moving parts and ensure everything runs smoothly. The internal combustion engine has evolved a lot over the years. We now have turbochargers that force more air into the engine for more power, fuel injection systems for better efficiency, and advanced computer controls that adjust everything from timing to fuel mix. These improvements have made modern engines far more powerful, fuel efficient, and clean than their earlier versions. Speaking of clean, this is where things get interesting. Despite their amazing engineering, ICEs produce emissions like CO2 and nitrogen oxides, which contribute to air pollution and climate change. That's why the automotive world is gradually shifting towards electric vehicles and hybrid technologies. But make no mistake, the internal combustion engine still dominates the road and remains a mechanical marvel of precision, timing, and controlled explosions. Before we wrap up, let's take a quick look at some of the most iconic uses of internal combustion engines, from roaring V8 muscle cars to high-revving motorcycle engines, and even Formula One race cars that push these machines to their absolute limits.